You see, whenever I look at a problem in physics, I always ask the same question. What is the arrow pointing to? Not the arrow on a map. I mean the arrow of time, the arrow of change. You see, nature has a very funny rule, a rule that we do not like very much. It says that you can scramble an egg, but you cannot unscramble it. You can turn a glass of wine into a spill on the rug, but you cannot turn the spill back into a glass of wine. There is a direction to things. There is a flow. And if you try to swim against that flow, you have to pay a price. And usually the price is energy. The price is order turning into disorder. Now people ask me, Richard, what do you think about going to Mars? And they show me these beautiful pictures of rockets and domes and people growing potatoes and red soil, and it looks wonderful. It looks like an adventure. It looks like the next chapter in the great human story. We went to the moon, so naturally we must go to Mars. It is just the next stepping stone, right? But I have to stop them. I have to say, wait a minute. You are thinking about this like a geographer. You are looking at distance as if it is just miles, as if it is just space. But in physics, distance is not just space. Distance is a relationship between forces. And when you look at the forces involved in going to Mars, and more importantly, the forces involved in coming back, you realize something terrifying. It is not a stepping stone. It is a trapeur. And I do not mean that in a sci-fi way. I do not mean there are monsters there. I mean that the laws of physics, specifically the laws of thermodynamics and the laws of biology, have conspired to make it a one-way trip, not because the rocket breaks, but because the passenger breaks, because you break. Let us start with the first trap, the trap that is waiting for you right on the surface, the dust. Now you might say, Richard, it is just dirt. We have dirt on Earth. We have sandstorms in the Sahara. We deal with it. We have brooms. We have vacuum cleaners. What is the big deal? Well, let me tell you about the history of a grain of sand on Earth. It is a very violent history, but also a very smoothing one. On Earth, we have water, we have rain, we have oceans. For billions of years, every grain of sand on Earth has been tumbled around. It has been washed. It has been rolled back and forth by the waves. Imagine you take a jagged piece of glass and you put it in a rock tumbler for 1,000 years. What comes out? A smooth marble. It is round. It is soft. If you rub it between your fingers, it feels like powder. That is earth dust. It is friendly dust. But Mars is a dead world. It has been dead for a very long time. There is no rain. There are no rivers. There are no oceans. The only thing that happens to the rocks on Mars is that they get hit. They get smashed by meteorites, big ones and little ones. For 4 billion years, rocks have been smashing into other rocks. So when you look at a grain of Martian dust under a microscope, you do not see a marble. You see a shard. You see a knife. It is jagged. It has edges so sharp they are almost 1 molecule thick. It is not dust. It is microscopic broken glass. And it gets worse. Because Mars is so dry, there is no humidity to conduct electricity away. So these little shards of glass, they pick up a charge. They become electrostatically charged. They are like little magnets. Now imagine this. You land your ship. You need to make fuel to go home. You cannot bring the fuel with you because fuel is heavy. If you tried to bring the fuel to get back, you would need a rocket the size of the Empire State Building just to launch the fuel. So you have to make it there. This is what the engineers call in situ resource utilization, a fancy name for digging up stuff and burning it. You need to mine the ice from the ground. You need to suck the carbon dioxide from the air. You need to run pumps. You need to run compressors. You need to have seals that rotate. You need bearings that spin. But here comes the dust. This magnetic broken glass, it does not just sit on the ground. It levitates. The electric fields lift it up. It floats in the air, and it sticks to everything. It sticks to your solar panels. It sticks to your suit. And most importantly, it sticks to your machines. It gets into the bearings. And because it is harder than steel and sharper than a razor, it grinds the bearings down. It eats the metal. It gets into the rubber seals of your airlock, and it cuts them to ribbons. You try to wipe it off, but you cannot wipe it off because it is magnetic. When you try to wipe it, you just grind it in deeper. So there you are. You are the greatest engineer in history. You have built this magnificent factory on Mars to make your rocket fuel, but the factory is destroying itself. The gears are seizing up. The valves are leaking. The solar panels are covered in a layer of brown soot that you cannot wash off because there is no water. Physics is fighting you. The electrostatic forces are fighting you. The friction is fighting you. And you realize that the machine you built to get you home is dead. But let us be optimistic. I like to be optimistic. Suppose you solve the dust problem. Suppose you invent some magical material that the dust cannot cut. You make your fuel. You fill up the tank. You are ready to go. Now we have to look at the second trap. And this one is not about the machine. This one is about the meat. This one is about you. We have to talk about radiation. Now, people hear the word radiation and they think of glowing green slime or nuclear bombs. But radiation is actually much simpler and much scarier than that. Radiation is just little bullets, tiny particles, protons, helium nuclei, moving very, very fast. How fast? Nearly the speed of light. On Earth, we are spoiled. We are incredibly lucky. We have two shields. We have the magnetic field of the Earth, which catches these bullets and spirals them away to the poles, which makes the northern lights. And we have the atmosphere, a nice thick blanket of air. By the time a cosmic ray reaches you on the surface of the Earth, it has hit so many air molecules that it is tired, it is weak, it is harmless. But between Earth and Mars, there is nothing. It is a shooting gallery. The sun is shooting protons at you. The rest of the galaxy is shooting heavy ions at you. When you are in that spaceship for 6 months going to Mars and 6 months coming back, you are standing in the middle of a firing squad. Now, what happens when one of these bullets hits you? You are made of atoms. You know that? Hydrogen, carbon, oxygen. And these atoms are glued together by electrons. The electrons are the glue. They hold your molecules together. They hold your DNA together. When a high-energy cosmic ray comes screaming through your ship, it ignores the walls. It ignores the hull. It goes right through your skin and it crashes into your atoms. It hits the electrons and knocks them flying. It is like taking a bowling ball and throwing it at a house of cards. The structure collapses. The chemical bond is broken. This is called ionization. Now, your body is amazing. It is a miracle machine. It has repair crews. Inside every one of your cells, there are little proteins that run around looking for damage. They see a broken piece of DNA and they say, hey, let us tape this back together. And usually they do a good job. But on the trip to Mars, the damage is happening too fast. It is like trying to fix a roof while a hurricane is blowing. The repair crews make mistakes. They tape the wrong pieces together. They connect a gene that tells the cell to grow with a gene that tells the cell to stop. So the cell gets confused. It forgets what it is supposed to be. It thinks it is supposed to just grow and grow and grow. That is cancer. But that takes time. Cancer takes years. You might say, Richard, I can take the risk of getting cancer in 20 years if it means I get to walk on Mars today. But there is something faster. There is something that happens before the cancer. Your brain and your kidneys. You see, nerve cells do not replace themselves very well. When a high-energy heavy ion hits a neuron in your brain, it leaves a track of dead tissue. It is like a microscopic bullet wound over a long trip. Your brain is literally being Swiss cheesed. You start to lose cognitive function. You start to forget things. You start to get confused. Imagine trying to land a spaceship when you cannot remember which button does what because the part of your brain that remembers buttons has been destroyed by a particle from a supernova 1,000 light years away. And the kidneys are the filters of the blood. They are very delicate structures. They are made of miles of tiny little tubes. Radiation hates these tubes. It scars them. It makes them stiff. So here's the scenario. You have survived the dust. You have made your fuel. You are halfway home, but your kidneys are failing. Your blood is full of toxins because the filters are broken. You need dialysis. You need a machine to clean your blood, but you do not have a hospital. You are in a tin can, millions of miles from the nearest doctor. You die not because the ship failed. You die because the physics of the universe tore your biological machinery apart at the atomic level. But wait, it gets worse. There is a third trap, and this is the one that really keeps me up at night, because it is so subtle, it is so elegant. It is the trap of gravity. Gravity is a mystery. Isaac Newton gave us the math for it, but he did not know what it was. He said, "I frame no hypothesis." He just knew that things pull on each other. Einstein came along and said, "It is not a pull, it is a curve." Space itself is curved. But however you want to picture it, gravity is the force that shaped you. Every muscle in your body, every bone, every valve in your veins is designed for one thing: to fight Earth, gravity, to fight 1G. Your heart is a pump. It is a fist-sized muscle that has to squeeze hard enough to shoot blood up against gravity to your brain. It works hard, beat after beat, day after day. It is like a weightlifter holding a barbell. Now you go to Mars. Mars is small. It has weak gravity, only 38% of Earth. Suddenly your heart says, "Hey, why was I working so hard? This is easy. I can relax. I do not need to push so hard to get the blood to the brain." And you know what biology does when it does not need something. It throws it away. Biology is very efficient. It says, "We are wasting energy on this big heart muscle. Let us shrink it." So your heart gets smaller. It gets weaker. It literally changes shape. And your bones, oh, the bones are the worst part. You think your skeleton is like a steel frame inside a building, but it is not. Your skeleton is a bank. It is a bank for calcium. On Earth, you are constantly making deposits and withdrawals from this bank. Your body puts calcium in to make the bones strong, to hold you up against gravity. But on Mars, your body says, "Hey, we do not need this heavy frame anymore. We are floating around. It is light here. Let us make a withdrawal." So the cells that eat bones start working overtime. They dissolve your skeleton. They dump the calcium into your blood. Your bones become porous. They look like a honeycomb. They look like chalk. Now this is fine as long as you stay on Mars. You have become a Martian. You are adapted to the environment. You are a low-gravity creature. But remember the title of this talk, No Way Back Home. Imagine you try to come back. You get in your ship, you float for 6 months, your bones get even weaker, your heart gets even smaller, then you hit the atmosphere of Earth, you are pulling G's, the deceleration is crushing, but let us say you survive that. The capsule splashes down in the ocean, the hatch opens, you see the blue sky, you smell the salt air, you try to stand up to walk out of the capsule, and you collapse. Because suddenly you are back in 1G, but you are trying to fight it with a 38G body. Your heart, which is shriveled up, tries to pump blood to your head, but it cannot do it. It is too weak. The gravity of Earth pulls the blood down into your legs. Your brain is starved of oxygen. You faint. Your bones, which are now made of chalk, try to support your weight, but they cannot do it. They snap. You suffer multiple fractures just from trying to stand up. You are being crushed, not by a rock, not by a monster. You are being crushed by your home. You are being crushed by the very environment you were born in because you are not you anymore. You have changed. The planet Mars has re-engineered you. It has taken your biology and it has twisted it to fit itself. And this brings us to the deepest point I want to make. The point about systems in physics, we talk about isolated systems, but in reality, nothing is isolated. You are not separate from the Earth. You think you are an individual walking around on top of a planet, but you are not. You are part of the planet. You are an extrusion of the planet. You are made of Earth materials. You are tuned to Earth gravity. You are shielded by Earth magnetic fields. You are part of the Earth system. When you leave that system, you are like a fish jumping out of the water. A fish can jump out of the water for a few seconds. It can see the air. It can see the sun, but it cannot live there. If it stays there, it dies. We think that because we have technology, because we have rockets and computers, that we can cheat this rule. We think we can build a fish tank and carry it with us. But the tank is leaky. The radiation gets in, the gravity gets out, the dust gets in. The universe is always trying to bring you into equilibrium with your surroundings. On Mars, equilibrium means death, or at the very least, it means becoming something that can never leave Mars. So when I see those plans for colonization, when I see the timelines that say we will have 1 million people on Mars by 2050, I have to laugh. But it is a sad laugh, because they are ignoring the fundamental laws of nature. They are treating biology like software that you can just patch. But biology is hardware, and it is hardware that took 4 billion years to develop for exactly one environment, this one. Does that mean we should not go? No. I am an explorer. I believe in curiosity. I believe we should send our eyes and our ears. We should send robots. Robots are wonderful. They do not get cancer. Their bones do not dissolve. They can sleep in the dust for 1,000 years and wake up and say hello. But for us, for these sacks of water and protein that we call human beings, we need to be humble. We need to realize that we are not the masters of the universe. We are the children of Earth. And like all children, we can wander a little bit. We can play in the backyard, but at the end of the day, we have to come home. And if we go too far, if we cross that dark ocean to that red dot, we might find that the door has locked behind us. We might find that we have become aliens on our own home world. So look at that pale blue dot. That is where you belong. That is where the air is sweet and the gravity is just right, and the magnetic field wraps around you like a warm blanket. Do not take it for granted. It is the only house you will ever